वक्रतुण्ड महाकाय सूर्यकोटि समप्रभा निर्विघ्नं कुरु मे देव सर्वकार्येषु सर्वदा सर्वकार्येषु सर्वदा सर्वकार्येषु सर्वदा गुरुर्ब्रह्मा गुरुर्विष्णुः गुरुर्देवो महेश्वरः गुरुर्साक्षात् परब्रह्मा तस्मै श्री गुरवे नमः।
Namaste. Welcome everyone to yet another Yes Talk. Today we have with us Professor Anurag Agarwal. Welcome, sir. I will briefly introduce him before we get into the session with him. Professor Anurag Agarwal is Dean Biosciences and Health Research, Trivedi School of Biosciences, Ashoka University. He has completed his graduate medical studies from AIIMS, and further he went to US for training in internal medicine. And then he came back to India and did his PhD in physiology from the Delhi University. His prime research interest is in respiratory biology, and broader interests are in a new vision of health and healthcare seen through the lens of emerging technologies, for which he serves on numerous national and global advisory groups. During the COVID-19 pandemic, he led molecular surveillance efforts and chairs the Viral Evolution Technical Advisory Group at WHO. He received the Shanti Swaroop Bhatnagar Prize in 2014, the Sun Pharma Foundation Award in 2020, and he is a fellow of the 3 Indian National Science Academies. We welcome you, sir. Looking forward for your session. Over to you.
Thank you very much. It's a pleasure to be here. And Professor Bijlani, of course, is my super senior, the original person who took physiology as a career. So glad to be following in his footsteps. I'll share my screen. I'm guessing you can see my screen by now. So what I thought I would talk to you all about are insights into the COVID pandemic. And as you know, there have been lots of controversies, lots of speculations, lots of fears. But knowing the data does make it somewhat easier for us to understand the likely course. I would like to start off by showing you a picture. Japanese schoolgirls wearing masks while going to school. Newspaper headlines, keep church windows open, draft men, meetings to be cancelled. And of course, this is not from now. This is the influenza Spanish flu outbreak from about 100 years ago. It reminds you of the French quote, which I don't know well enough to speak in French, but the more things change, the more they remain the same. So let's see what in COVID-19 has followed an expected pattern, which makes it predictable, and what is unexpected, and how we can look at it scientifically. I would start by showing you a really interesting graph. It's a graph showing percentage of deaths on the y-axis and age group on the x-axis. So remember, these are not absolute deaths. Obviously, older people in absolute terms die more. These are percentage of deaths attributable to the Spanish flu in data from North America. Very interesting. What you see is that it's very low in older people and peaks between 10 to 40, which is not the time when people normally have high deaths. And so it must mean something. The best explanation we have today is that the Spanish flu was very different from other flus. The last such flu had come almost 40, 50 years ago. So people aged greater than 40 had been exposed to the previous flu that was like the Spanish flu and were relatively fine immunity-wise, while those people who weren't did badly. And within that, generally it is known that unless you are in the first year of life, children are less likely to create big immune storms. So there was a pattern that one could somewhat explain by saying the last such flu was about 40 years ago. In contrast, I would like you to look at this graph. The relative risk of death with SARS-CoV-2 a century later rises exponentially with age. You can take data from any continent, any country, it looks about the same. What it tells you is that more than 1 billion people, when they got infected, probably 5 million dead, almost nobody anywhere in the world had much of an immunity. You could argue looking at this that perhaps Asia, some parts of it, did a little bit better, which may be expected because the nearest relative of SARS-CoV-2 in humans would have been SARS-CoV-1, which was primarily East Asian. But essentially, what this graph is telling you is that the problem with SARS-CoV-2 was that it was so different from any other virus that had previously come that there was no effective background immunity amongst humans, or at least none that we can see from these distributions. Was it a totally unexpected pandemic? Had nobody predicted it? Not really. The title that I show you in the bottom is a SARS-like cluster. Let me switch that, yeah. Of circulating bat coronaviruses, which showed potential for human emergence. You can see this is a paper from 2015. And from 2002 novel coronaviruses, SARS-CoV-1 and MERS had already crossed the species barrier. They had a higher mortality actually than SARS-CoV-2 on a per case basis, but the infectivity was lower, so they didn't spread as much. So one could argue that a SARS-CoV type of coronavirus, the beta coronavirus family, creating a pandemic was somewhat predicted, but not predicted with enough confidence that people actually would have taken any steps towards it. So this is the official version of how it started. You can see very early end of November, first patient is identified. By December 8, patients with pneumonias of unknown etiology reported. December 31, WHO is told. January 7, the sequencing is done. The sequencing is shown here on the left. Please don't bother too much about it. All it shows is related to some bat coronaviruses. By January 12, it has a name. What is not on this graph is that based on the sequence alone, by January 26, Moderna has a mRNA vaccine design that has started. In fact, that is the same design that finally went on to become the vaccine and could have been synthesized within a month. So if we were to take things without testing, which we shouldn't, within a month of the identification of the sequence of the coronavirus creating the pandemic, a vaccine that later turned out to be effective was invented. So that's one important lesson of what is different this time versus the old Spanish flu. Many people ask, is there any evidence that the virus was circulating earlier, perhaps in biolabs in China? We do have some evidence for earlier circulation. And the most important evidence is from this paper that people can look up on their own if they're interested. it shows that Antarctic soil metagenomic sequencing data, the soil samples were collected in 2018, 2019. They were sequenced much later, around November. So there are two possibilities. One is that SARS-CoV-2 was present in Antarctica soil. That is very unlikely. The other scenario is that other samples being sequenced in the same facility in Shanghai also had SARS-CoV-2 being sequenced in the same place. So that lets you know that perhaps SARS-CoV-2 was at least there by November 2019, and clearly sequencing was happening at that point in time. But this is the only other evidence that currently is there, and this could have been a contamination, of course, but even contamination would argue that this virus existed at that point in time. So that's about as much attention as I will put on the conspiracy theories. I don't think we'll ever find out whether it was lab made or lab grown. All that we can say is it was a virus under study, natural or not, in China, probably by November 2019. So if we were to look at mildness in terms of number of infected people who die, COVID-19 is actually much milder than the Spanish flu. It is in fact much, much milder than even SARS-CoV-1 or MERS. The problem with COVID-19 is that it has tremendous ability to propagate, minimal prior immunity, huge numbers, and a very small fraction of a very large number is still a large number. We further saw the virus evolved, possibly because of bad luck, possibly because of huge numbers of infection, to fitter variants with greater airborne transmissibility and reduced susceptibility to the immune response induced by the initial variants. And that led to the virus creating repeated surges and not ending with one big surge. One such surge was the Delta surge in India that overwhelmed healthcare systems, despite no real change in low infection fatality rate. This is important. All Indian data, all global data for Delta does not actually show that Delta was actually that much more fatal than the initial versions. It simply was much faster propagating, overwhelming healthcare systems, leading to far more really sick people. And during a Delta wave, less sick people would rarely get tested, leading to a temporary overestimate of case fatality that would later on correct as the overwhelming situation went away. I'm not going to spend much time on this because I don't know how many of you are interested in genomics, but genomics is a way in which we can measure every base of the sequence of the virus, which is composed of around 30,000 nucleotides. We do this for a variety of things, including to investigate spreads and clusters, infectivity, severity, jumping between animal to human, human to animal. That also happens, by the way. Plenty of cases of infections going from man to his dog that we know of. In India, in 2020, this kind of an effort, we were sequencing the genomes, was small. In 2020, only 8,000 samples were sequenced. 2021, it picked up. Over 100,000 samples got sequenced. 2022, it's picked up even further. Almost, I think, 50,000 samples have been sequenced in the last few months. I don't expect you to look at this graph very carefully, except the distance between branches shows you how different they are. All that I want you to see is that the initial variants of concern, called alpha, initially found in England, beta, initially found in South Africa, and gamma, initially reported in Brazil, were actually quite close to each other. If you compare them, you can see Delta was far away. And what you can see is Omicron is pretty much as extremely far away can be on such a plot. So basically what I would say, which is important for you to remember, pandemics end when immunity is sufficient. Immunity can only be to related sequences. As sequences become different, immunity's effectiveness declines and fresh outbreaks occur. There is a mutation that is never listed as a variant of concern called D6. Anyway, I'll not bother you with this, but this does not have a name. If we had a naming system, that would have been alpha, and everything else would have moved forward by one. Let's talk about the pandemic in India to understand how things happen. All of us know that India had two big waves in 2020, 2021. Of course, we'll come to Omicron later. We know that in Delhi, there were more than two waves, and you can see how Delhi looked like. A wave in June, a wave in September, another wave in November. This is all 2020. And then, of course, the massive wave, probably all of us can never forget. So this was the situation in early 2021. We, along with government of Delhi, were doing sero surveys. Sero surveys measured how many people had been previously exposed and infected. Delhi had, in January 2021, overall seropositivity of 56%, ranging from 49 to 62% across 11 districts. In CSR, we had our own cohort. Our people are a little more protected, more educated, higher income. But even our seropositivity using state-of-art methods was 42%. And it was very clear by that time, if you are infected once, even if you get infected a second time, it's unlikely to be severe. It was thought you are unlikely to transmit. So many people claimed by January to February 2021 that perhaps the worst was over and life could get back to normal. And this was despite knowing what was happening in Manaus, Brazil, when despite seropositivity having hit 55%, they had a massive wave in which they had oxygen shortages and everything else due to the gamma variant. The other mistake that we were making, we were assuming that the variants of concern we have to worry about would be coming from outside India. So all our efforts were driven by looking at those bad things coming from outside India, corrupting us, but not looking inside for trouble, which actually, in retrospect, makes so little sense because we've always known to get 56% seropositivity in Delhi. Imagine the true number of infections. Even today, if you were to take known infections and try to calculate what seropositivity would be, you will not even cross 5%. So our real cases have always been more than 10 times in the best places, Kerala being the only exception, where the number is 2 to 3 times only. But pretty much anywhere in India, on average, the true number of cases is 15 times the known cases. That's what the sero surveys show. So in Maharashtra, around that time, a mutant was found. This is February data coming out of VJM Medical College. They described these mutations in February. This data was also available by end February, beginning March, where you could see that the proportions of this particular mutant, and that time we are not split into delta and kappa, they were all being considered together, called B.1.617, was rising along with the rise in positivity. On basis of this, initial alerts were given that we may have a new variant in Maharashtra that is driving the outbreaks there. And those alerts typically came by the first week of March. Problem was that it's hard to know from just this, whether it's going to be very severe, whether it's going to be not so severe, whether it's going to bring the country to its knees. Many people felt that Maharashtra was not managing it well, and perhaps the Maharashtrian experience was attributable to their poor ability to manage things. So unfortunately, whatever be the reason for thinking that way, no further major action got taken. Because everybody was thinking that with the big cities, high seropositivity, maybe this will go away, maybe nothing too bad will happen. By April, things became much worse. In April, we also realized something we did not know in March, that there were actually two subvariants within B.1.617, one later called Kappa, one later called Delta. Kappa was actually predominant in Maharashtra at that time, which made it look milder than it probably was, while Delta turned out to be much faster propagating than Kappa, and that was responsible for the big outbreak in Delhi. So there were some reasons for the Maharashtra data to be confusing. And of course, in retrospect, one would always say it is better to prepare for the worst and hope for the best. Again, this slide I will not talk to you too much about, except to say that when you look using computer simulations, you could see that these mutations would lead to an escape from immunity. They would lead to better binding and entry of the virus to human cells. This is a piece of data that I believe should have been given far more importance than it was. We published this one later along with the Imperial College group. This is a hospital in Delhi. Many doctors who are either vaccinated, double vaccinated is dark blue, not vaccinated is very light blue, and one vaccination is intermediate color. And you can see a big cluster broke out in these fully vaccinated doctors. Most of them are fully vaccinated. And they're getting almost identical virus, suggesting they're getting it from each other. And turned out they were having coffee towards the beginning of April together. So this was the next signal that was important, that fully vaccinated doctors who were supposed to be resistant to infection, 70 to 80% of them, by sitting together and having coffee in a closed room, managed to get infected. This would have, of course, then explains what came later. What came later was this. You can see that cases were down to almost nothing. But by 12th April, test positivity rate was starting to hit 30%. And these were large number of tests being done. You can see hospitalizations quickly started to peak, such that by the end of April, we were almost running out of beds. These are ICU admissions that I'm pointing out over here. And I would like to point out this hump. You know, and I know this is not a natural hump. It is not because we did any better at preventing people from getting sick. We basically ran out of ICU beds. And as we added ICU beds, they kept on going up until, of course, later on there was a decline. The ratio of deaths to cases was remarkably constant throughout. This is a cumulative plot of cases and a cumulative plot of deaths, and except towards the end, the ratio barely changes. Again, suggesting that Delta was very highly transmissible, broke through previous immunity, including double vaccinated doctors, created sickness at a relatively similar fraction as past, but because there were so many infected people, far beyond our capacity to imagine, the total number of sick people presenting to hospitals and ICUs became more than we could handle. And this shows the sequencing. This purple color is Delta. What you can see is from March to May, it removed everything else. It became all Delta. And that was the same time as the peak. So it's very safe to say that Delta caused this peak. And this paper also was published by us recently. And we did mention in 12th April a lot of this data to WHO. So it was not that India did not warn, except that perhaps a month earlier would have been nice. Then, of course, Delta rose across India. From state to state, it was the same story. And the reason Delta spread so well is because you can see CT values are so much lower during the Delta wave compared to before. And that's because the viral load of Delta is much, much higher. Even higher viral loads were reached later in the noses of people with Omicron. But you can see 100 to 1,000-fold differences were seen in culture, and 10 to 100-fold differences were seen in actual human noses. And again, both of these papers, people who are interested in the science of it can look. We got a lot of insight from cohorts we ran. So this paper is now published. It's in Nature Communications. We got lots of insights from vaccinated healthcare workers. We realized that, levels of antibody sufficient to neutralize wild type virus, that's you can see here in blue, 1:20 is reasonable neutralization. Anything above is, good with neutralization. And you can see antibody level of around 100 was enough after AstraZeneca vaccination, Covishield. But you need 10 times of that, 1,000 or more, to neutralize Delta. This number goes to 3,000 or so for Omicron. And what you see here is the vast majority, almost half, of healthcare workers who are uninfected got infected during the Delta wave. We were able to calculate the effectiveness of vaccine. It was effective in preventing infection, about 65% effectiveness. That 50% infection includes people who had single vaccinations. So double vaccination had 65% effectiveness. Single vaccination had barely any effectiveness. It was, however, excellent at reducing disease severity. There were very few people who got really severe disease after Covishield vaccination, after 2 full doses. But the problem is, number of people who had 2 full doses were very few. We did get a few cases who, despite 2 full doses of Covishield, had severe disease. Most of them were older people with poorer immune response based on our data. In the end, we were able to show the Delta variant had 2 properties. About a 40% higher ability to escape prior immunity and about a 60 to 70% higher fundamental transmissibility. You combine the two, you're looking at 3 times higher transmissibility than past, and that led to the Delhi outbreak. So what ended the wave? This is again serology data from our cohorts. What I want you to see is that in January 2021, public transport users had a high seropositivity. Our house cleaning staff had almost 60% seropositivity, like Delhi government. Our scientists using their own cars had only 30% seropositivity. At the end of June, all of them had the same seropositivity, 90%. No matter who you were, no matter what was your ability to protect yourself, 90% got infected. These are not vaccinated people. These are not doctors. These are primarily unvaccinated scientists, students, ordinary workers of my institute. We saw plenty of reinfections. In our cohort, we estimate that about 25% of people got reinfected. But all reinfections were mild, just like most vaccination infections, breakthroughs were mild. Which brings me to the very important part, the biggest insight, the most important insight. Vaccination clearly saved lives. And I love this graph from the Financial Times. I don't think I have seen anything much better than this. On the top, and remember the top and the bottom have different scales. The top are infections, the bottom is death. So blue are infections, red are deaths. This is the time in UK when most people get vaccinated. Look at what happens when the blue rises again. The red doesn't rise. Same thing happens in Portugal. The same thing does not happen in Namibia because vaccines don't reach. It doesn't happen in Tunisia. It doesn't happen in South Africa. It doesn't happen in Indonesia. Don't worry about the number of cases. India detects very few cases. Indonesia detects even less cases. South Africa detects few cases. UK detects most cases. And this you can tell by taking the known cases and the zero surveys. Just look at the ratio between the blue and the red. See the difference vaccination makes. At the time of the Delta wave, India was not a vaccinated country. India had only 5% vaccination, which is why Delta wave behaved the way Delta wave behaved. This is our all India data, which again will be important. What you can see is, even in June, when after the lockdown, COVID was not supposed to have spread throughout the country, you can see about a 10, 15 to 20% seropositivity across the nation. By January 2021, you can see 28% seropositivity across the nation. ICMR number was 24. And remember, this number of 6.6% in June 2020, if you look at the official cases per unit population, we still haven't crossed this 6.6%. And look at this in July, August 2021. No matter where you are in the country, there were a huge number of cases. But note the other important thing. Delhi, Lucknow, so these are across CSR labs. So our labs, very similar structure across multiple cities. So you can use our labs to say that despite far higher known cases in Kerala, the actual seropositivity in Kerala was far lower than Delhi or UP. So that's again an important lesson to learn. Do not believe the numbers that come regarding the number of cases, the control of cases, none of it is real. The only reality is told to you by sero surveys, and the sero surveys show there is barely any difference in terms of the spread of the disease during the Delta wave across the nation. In fact, those which had a long Delta wave are the ones who actually had lower seropositivity and therefore had less infected people, and the wave ran longer. The places where the wave ended fast, it ended fast because their seropositivity had already started hitting 80%. So pretty much the wave went on until either everyone got vaccinated for Delta or until almost everyone got infected or a combination thereof. Wherever it ended, it was because of immunity becoming high. And those where it ended fast, it was not because of vaccination. Those where it ended late, maybe there was a huge contribution of vaccination. But nevertheless, India did a phenomenal job in vaccinating 1 billion people by the end of December 2021. It is not a small task. It's a little more difficult to calculate the effectiveness of Covaxin because it also creates antibodies to other proteins, not just the spike. But again, this again is now published. We analyzed and found Covaxin efficacy to be around 56%, which corresponds nicely with the AIMS data, which showed around 50%. So Covaxin was also effective. It was not effective. So, pretty much 56 or 60 are all the same numbers. Covishield and Covaxin were similarly effective. But on the other hand, you can also say clearly that any argument that because Covaxin had more proteins, it will be more effective is also untrue. India had 2 effective vaccines, both roughly in the same range. Minor differences in the median values, 156, 165, but practically all in the range of around 60. So our lab has been working hard on looking forward and trying to predict what happens as more variants come. This is, South Africa. You can see the Omicron outbreak. You can see how South Africa in 2021 suddenly started seeing cases all over again in November. You can see a huge surge after the Delta wave of Omicron. And this is a very important slide. Many people, including responsible people, spoke about Omicron as a vaccine. In India, remember, we had a huge number of infections, far beyond the cases, and then we had a huge amount of vaccination. The immunity in India was phenomenal, amongst the best in the world. But a lot of it because we had already paid our price. In a country like Denmark, Omicron led to a new surge, which you can see over here. And what you're looking is number of deaths per week. What you see over here is, times before it, maybe the Delta wave. And this is Omicron. And then they went back and looked at all the deaths to see whether the death was caused by the COVID-19 infection, or was it a case the person was anyway going to die, just Omicron caused the infection. What you can see is the number is smaller. There is no doubt about it. That dark orange, almost reddish color. But it's about half or maybe 1/3 of the Delta wave. It is not 1%, it is not 2%. In a country that did not have a huge previous infection, in a country that did not have hybrid immunity, Omicron was quite capable of raising deaths to a level of about 50% or about let's say 30 to 40% of what was seen in the Delta wave. And again, I'm not going to bore you with this. Basically, they show that 2 doses of vaccines were ineffective in preventing infection by Omicron. This is true for both Covishield and Covaxin, by the way. But you get a 3rd dose, the booster dose. Suddenly your immunity jumps up again. And that's why the booster dose is important. And once it becomes available to people of India, at most age groups and adult age groups, people should probably go ahead and take it. Just to illustrate how many mutations Omicron has, I had my colleagues plot this. Each one of these little lollipops in the spike protein is a mutation. That's alpha, that's beta, that's gamma, that's delta, and that thing that almost looks like a comb is Omicron. That's how mutated Omicron was, and that's why it was able to escape immunity. But even if it escaped immunity, it was milder because it was more nose, less lungs. But it was not only nose, never lungs. In a small fraction of people, particularly those without immunity, it could become severe. And we saw the best example of that in Hong Kong. I don't know how many of you are aware. In Hong Kong, in the 80 plus category, only 30% were vaccinated. And in that 30%, most had the Chinese killed virus vaccine, which was not very effective. And again, this is something that I don't think public got to know very fast, but by January 2022, it was all Omicron. The deaths that were being reported in India in January 2022 were not Delta, those were Omicron deaths. It was not that Omicron was mild, not causing any deaths, while all the deaths that were happening were because of Delta. That's again a narrative that's been skewed. Luckily for India, India has had more BA.2 than BA.1. So in India, the BA.2 outbreak is more or less over. Again, interesting thing was when we were sequencing airports, looking at BA.1, we've started seeing BA.2 coming in from this part of the hinterland. Bengal, Bihar, Uttar Pradesh, Madhya Pradesh, Odisha, where the monitoring is less, and BA.2 was just spreading throughout the country, which is why the wave ended pretty fast. And I'm not going to bore you with this. BA.2 is faster than BA.1. Everybody knows that. Today, we have a lot of hysteria going on about recombinants. Are they real? Yes, they are. There are many of them, XD, XC. In fact, recombinants have always occurred. It's only because Delta and Omicron are so different from each other that a recombinant of the two is very easy to pick up. I don't see any great reason to worry based on the current global data, and specifically given the Indian data of very high population previously infected and then also vaccinated. And we know that such cases, even if they get infected, tend to recover fast and without much disease. I don't think there's anything much to fear for India. Like I said, again, it is not because we did anything fantastically beyond our vaccination. It is simply because we have paid our price during the Delta wave, and then we have done a very good job of vaccination. And with that, thank you all. I hope this information was useful in understanding the COVID pandemic and feeling a bit more secure about the time to come. Thank you.
Thank you, sir. Thank you, sir.
We can take questions. If anybody has any question, they can ask now.
You just heard a very scholarly lecture by Professor Anurag Agarwal, and that is the type of presentation you expect from a person who is a scientist and has at the same time not lost the clinical touch. True physician scientist. If there are no questions, I thought I'll set the ball.
I am Dr. Gaurav, sir, from
Yes.
Sirsa.
Uh,
I have a question.
Yes, please.
Please wait for a while now. Just take your question. Since there was no question, I thought let me set the ball rolling by asking something which may be of greater practical value to the listeners, many of whom may not be medical scientists, how we get back to life from where we are today.
I think
Yet another wave in June, which is being talked about, and things which the general public might be interested in.
Yes.
So I have a question. Sorry. Any recommendations for fourth dose before that June epidemic, which people are saying may come, or
Sure.
just...
I'll answer both of these together.
Thank you, sir.
So the intent of showing what happened in the Delta wave and then the vaccination, then Omicron, is basically that Indians have very high immunity by now already. we don't expect there to be a massive rise in severe cases, even if there is a rise in infections. That has been the experience throughout. Vulnerable groups should go in for boosters, which is what the point I was making, and booster is a third dose. I don't see any merit in the fourth dose for India at this point. The current circulating variants are BA.2, which India has already had. And of course, even if you have a recombinant with Delta wave also India has had. So our existing immunity is sufficient to take care of both of these, which pretty much means that in India, we have nothing much to fear in the immediate time to come. However, it is always better to be uninfected compared to infected. So reasonable precautions like masks when you are in indoor, crowded, poorly ventilated spaces is one way. Not going to poorly ventilated indoor, crowded spaces, if you can avoid it, is the other way. When you're outdoors, at this point, given the low amount of COVID in the community, there is no particular importance of masks. So which is why removal of masks, getting back to business, at least outdoors, is absolutely fine and rational, as per me. Getting back to schools, universities, colleges is also very important as per me. And again, as long as ventilation is adequate, I don't actually see much else needs to be done. We have already developed enough immunity. Until the next variant comes, which would be very different, and we will see the signals when it comes. So until then, we can get on with life. I see a hand up by Prasida Menon.
Thank you, Dr. Agarwal, for that wonderful, very scholarly, very technical presentation, but I think we could still understand a lot of it. I have a question related to adverse events after vaccination. So I have a friend of mine who stays in Bangalore. Her mom, I think she must be 60 plus easily. When her mom took her first dose of vaccination, the very second day she had a stroke. And so I think she was alive for 2 or 3 months, and finally she passed away. So I wanted to know, like, we cannot really say that it is because of the vaccination that this happened, but today she takes the vaccination and tomorrow she suffers from a stroke. So, and recently my husband took his booster dose, and in the morning he was fine. When he returned after the booster dose, he sometimes has sciatica pain. So that started again. And again, we were like, we couldn't understand whether we should attribute this to the booster dose or something else. So what about adverse events?
Great question. So I'll first answer the question by a bit of the sad part, which is that within India, we don't collect the VE data at a high enough quality to give you a specific answer for Indians. But there is a tremendous amount of global data for at least one of the 2 vaccines that we use, which is Covishield. And that shows very clearly that there is an increased risk of thrombosis, primarily in women, typically in young women. And the risk can be somewhere in the range of 1 in 50,000 to 1 in 100,000. If you very specifically look at young women, it can be as high as 1 in 30,000. However, now let's also look at the risk of thrombosis if you get COVID. The risk of thrombosis if you get in COVID is in the range of 1 in 1,000 for an older person. So the benefit versus risk of staying unvaccinated is such that even if you are older, you would prefer an effective vaccine that carries a 1 in 30,000 risk of thrombosis. And the true number is probably closer to 1 in 250, but I'm telling you all international data. This is not Indian data. And knowing that we are not able to pick up such thrombosis in our VE system, then makes you, of course, worry. But by and large, killed virus vaccines are reasonably safe. A lot of experience is there with them. So you would expect Covaxin to be safe. Again, I'm not speaking based on data, I'm speaking primarily based on expectations. And of course, We have enough data to know that it's not 1 in 1,000. We know it's not 1 in 10,000, but we may not be able to pick up 1 in a lakh. So what typically was being done by people looking at this for young women, we would typically prefer Covaxin to Covishield. For older people who wanted that little extra 10% protection, we would prefer Covishield to Covaxin. But there is no hard and fast science on this. But your concerns about vaccine side effects are genuine. But when you put together the risks of thrombosis and everything else from COVID itself, just today there is a nice paper in BMJ showing triple risk of thrombosis. And the other important data that came out recently shows that starting 1 month after COVID to 1 year after, the risk of strokes is up 5 times. The risk of heart attacks is up 2 times, even in people who had mild COVID only. So by and large, there is value in using vaccines, including boosters, to stay uninfected if one can. But at the same time, there is no value in going crazy about it and shutting down life completely. So with some sensible precautions, I think life can go on. I hope that helped. And by the way, just in case any of you are reading about mRNA vaccines, the same issue came for mRNA. The risk of getting myocarditis after an mRNA vaccine is, say, 1 in 100,000. The risk of getting myocarditis by getting COVID is 1 in 5,000 to 10,000. So again, you are far better off. So many people are there who got COVID and are still with persistent heart failure. There are almost no cases of people who got vaccinated and are still with persistent heart failure. So this analysis, but there's one important corollary. The younger you go, the less importance it is for the individual for vaccination. It may still be good for society to block transmission, but the current vaccines don't really block transmissions that well. So if I had a 5-year-old child who was, parents were asking for advice, do we get them vaccinated by taking them to America? I would say fine, the Indian policy is good enough. We're not worried about very young children yet. The risk benefit of vaccination in this category is not yet very, very clear, at least to me.
So there's a
I
question.
see a question by Amrita about value in combining different vaccines. Again, not enough data from India, but if you were to look at trials done in UK, you can see that 2 vaccines available in India. So basically what they did is they started with AstraZeneca Covishield, and they looked at 3 possible boosters. They looked at mRNA, which is not available in India. They looked at a killed virus vaccine, which would be similar to Covaxin, and called VLA, Villanova. And they looked at a third vaccine, which is basically a protein subunit vaccine, which is exactly the one that Serum is making now. So Corvovax and Corbevax. They found that substituting a protein subunit vaccine for the booster dose gave a 5 to 10 times increased immune response compared to using a third dose of Covishield, which gave a 2 times increase. And so in my personal opinion, if I had the option of taking a protein subunit vaccine for my third dose, that's what I would have taken. But in absence of that option, I would have gone ahead with the third dose as it is.
Can I ask my question?
Hi, Vishal. Yes, please.
Hi. Dr. Anurag, thank you so much for an insightful talk. My question is a very common question. How long does an immunity last after a second dose or after a third dose if such data is available?
Sure.
And if the immunity is lost by any chance, does it really make a difference on the type of next dose that we take?
Great questions. So when we speak of immunity, there are 2 types of immunity in our minds. One is immunity against infection, and one is immunity against severe disease. Immunity against infections is done by antibodies, which can block. And immunity against severe disease is done by cells, which can recognize and kill the cells that the virus has infected soon enough to clear the infection. Immunity by antibodies has a half-life of probably not much more than 3 to 4 months as things stand. It is a bit different for different types of vaccines. It is shortest probably for mRNA and longest probable for DNA. But again, that's but protein subunit may also be long. So what you can say is that immunity you gain against infections, these antibodies start declining by 5 to 6 months. And after 6 months, you should not necessarily assume that you have much protection against infection. These answers change based on context. People who are previously infected and vaccinated tend to have more stable big responses. And in India, most people are infected. So the answer for India is that once you have had an infection and 2 doses, or now most people are infection and 3 doses, or even if you don't know you had an infection, the likelihood is you will have reasonable immunity for a long time. And when you specifically look at the immunity against severe disease, it probably lasts for at least a year, if not more.
Thank you. And any suggestions on a third dose, which type of dose one could consider? In India, I think
if I could choose my third dose, I would have chosen a protein subunit vaccine. But all this safety, everything, all data probably needs to be looked at again in India. It is interesting to me how, because that WHO has already cleared it. It is interesting to me that when we have a vaccine and WHO clears it, we want the world to accept the data. But if somebody else has a vaccine and WHO clears it, we want to generate our own data. That's always a point of interest.
Thank you. Thank you so much.
Hi, I see Dr. Puneet.
Hello, Dr. Anurag. Thanks for the thanks for the informative such talk. Just one question was regarding the can we use the antibody levels? Suppose there's one doctor, can he use an antibody levels to guide the timing of the next vaccine dose? Related to this, there was an example in our hospital. One patient was had got a COVID in April 2021, and then was vaccinated in December 21 with the first dose of Covishield. And now in February, his by chance his antibodies were done, and antibodies were around 25,000. So we couldn't judge whether he should be now given the second dose after 3 months, or should we wait for the antibodies to decline somewhat. And is there any risk of now giving vaccine with such high doses of antibodies? I mean, this may be a scenario.
We have seen such cases many times because we measure antibodies. So we see that just one dose of vaccination after a significant infection gives you tens of thousands sometimes. Generally, we see that if you're talking about quantitative antibody levels, about 100 was good enough for wild type initial virus. About 1,000 was good enough for Delta. About 3,000 was good enough for Omicron. 25,000 sounds to be good enough for anything. And like I said, the half-life seems to be about 3 months or so. So probably you could easily wait a while longer before giving him. What is equally certain is that a person with such a high antibody response will be well protected against severe COVID because of also a high T-cell response. The reason I don't advocate antibody measurement is because I recognize the problem of the government. You cannot create a vaccination structure and policy for a nation based on measurement of antibodies because it is complicated, expensive, and difficult. But if you have access to the data, you could use it to guide therapy, but that's true for many guidelines as well. In the specific case you're describing, yes, I would push off vaccination by at least 3 to 6 months.
And any risk of getting him vaccinated with such high antibodies? I mean, if one person has such high antibodies, then is there risk?
Problem is there is no such data. If people get the antibodies level before, they would not vaccinate. Okay. And once you're vaccinated, it's usually done without knowledge of the antibody levels. But I would imagine not. Reason is, if this person with these high antibody levels was to get naturally exposed to the virus, we would think it is good that he has high antibodies. We would prefer him to be exposed to the virus at a time when he has high antibodies. So by the corollary, exposure to further viral proteins would not do very much. In fact, you would probably argue they will do nothing. They will immediately get bound and not much would happen.
Okay. Thank you. Thank you, sir. Thank you so much. Thank you.
Dr. Agarwal, you just mentioned that the antibody levels after vaccination come down after 3 to 4 months. But won't the memory cells be still there to respond in case there is?
Absolutely. But what happens is that, so SARS-CoV-2 is a quick disease. So let's say on day one, you get exposure, your antibody levels are down. They're going to be even lower in your airways because IgA is not there not much there with the current vaccines. Then your protection against infection is small. Once you are infected and the virus is replicating and the cells are displaying and the memory cells become active and the T cells also become active, then life is good. But that will take you 3 days. And what we are speaking of for most transmission scenarios is shorter than that. So COVID is a bit unusual in that when you are transmissible even before you become symptomatic. So from that standpoint alone, the antibodies are more important. And most people are thinking that a nasal vaccine giving you high IgA levels and local memory cells, creating immediate IgA response, finishing off the infection before it goes deeper, is what might work. As of now, they don't seem to be doing very much once they decline sufficiently. Also note that with the high mutations of Omicron, the levels that you need to neutralize are far beyond the initial levels reached by vaccination. And we do know that even your memory cells, even if they produce, will rarely cross the initial peak by more than 2 folds or so. So typically for most vaccines, it's not adequate, not to protect against Omicron.
If it is local immunity that is vital,
yes.
Then IgA, as far as I know, I mean, I may be wrong, IgA is concerned, it's relatively a non-specific antibody. The specific antibodies are the gamma globulins, not IgA. So would the general level of immunity of the person ensure that the IgA levels are high and local immunity?
In the case of SARS-CoV-2, you can have specific IgA to SARS-CoV-2 generated in the nasal mucosa because even in antibody maturation, yes, you do see G is more refined, but giving specific vaccines to that proteins in the nose, you can get specific IgA, specific enough IgA at very high concentrations locally. And people, what they have done is they have created nanoparticles, tagged them to multivalent spikes, given them in the nose, looked at production of multivalent spike IgA in the nose, and that is being seen as a pan-sarbeco vaccine, which will not only contain Omicron or current variants, but possibly contain most possible future variants as well.
If the local immunity can be induced by either the vaccine or by infection, the recent variants have been highly transmissible. And if we were to really test large numbers, we would find that almost everybody has been infected sometime or the other. So
I can tell you from my
would that not mean
because we
that
test everybody weekly,
who had a reasonably good natural immunity would have acquired good local immunity as well, even in spite of the vaccine? I mean, whether they were vaccinated or not.
Absolutely. So in our institute, we tested everybody every week simply because we could. And from the middle of December to the end of February, when we stopped testing, we found that 40% of our institute had given a positive test at some point or the other during this period. And of course, because we were checking weekly, we could have missed a few. So 40 could easily have been 60 as well. And most infections were very, very mild. But like I said, it is still not clear to anyone what the long-term consequences of infections are. And especially with the fears coming out, even from the original 1 year down of increased risk of thrombosis and more recently work on the brain. The virus is showing some brain effects. Still better to stay uninfected and not rely upon natural immunity. But if one is infected, one can go, of course, go forward with it. There's nothing to worry about either. But there's no reason to seek infection.
But I mean, just sort of continue the argument. We are ignorant about the long-term effects of the viral infection. We are equally ignorant about the long-term effects of the vaccine.
True.
And
but we already know 1 year data for both. So we have already seen in the V that the risk of thrombosis post-vaccination is not increased at 1 year. In fact, immediately starting from 2 weeks after the vaccine, it's a completely flat line. While when you look at post-infection, it peaks in the first month and then it stays elevated for an entire year. So this data we do have. So in that sense, for specific things that we are looking for, which is thrombosis, heart attack, strokes, autoimmune, it seems to be this way. There could be things that we are not looking for and not recognizing, of course, but that can never be told from the data. But for the things we are looking, vaccines look much safer than infection. Knowing that vaccines will only give you 50% protection at best against infection. Oh, I see a question by Abha Kolji about a kidney transplant 16 years back. So from my point of view, this is because of immunosuppression, it is even more important to be vaccinated. What can be done, however, is to test him for antibodies in case he's scared, because it's a risk-benefit analysis. Anybody who's scared should have the right to follow a particular line of thought. If their antibodies are already positive, then he may have got infected, in which case his natural immunity may be there partially. But for a patient that I was seeing, for specific advice they're asking, regarding my opinion, I would say vaccination is a good idea. And I would go with a protein subunit type of a vaccine, maybe Corby or something else like that. Again, when it's available, otherwise Covaxin's good. Less unknowns with killed virus vaccines.
That will be all.
I think your microphone is muted, sir.
There are no more questions. And with that, we thank you for sparing your time and giving not only a very enlightening lecture, but also taking up so many questions. Seems that the COVID is still at a high level. And thank you for helping and clarifying so many doubts that the audience had. And I'm sure many more will benefit from the talk when they go to the recording on the YouTube.
Thank you, sir.
Thank you.
Bye.
Thank you, sir. Thank you so much.
Bye. Take care.
Bye.